Databases aren't just for looking up things. We also aggregate, or we ask bigger kinds of questions, like who saw the most birds this month, or which are the most and least popular times of day for students to take classes, which are the most or least successful sports teams over the last decade. So all of those we think of as aggregation types of queries. It's one of the most important things we do, and it's not particularly difficult. So let's get started.
I shouldn't even say that aggregation is difficult because 95% of the time it's really straightforward. So let's dive in and take a look. And in the cases where it might get complex, we'll take a look at those. So I'll show you how to work with the 5% of cases that are difficult. All right. So let's imagine that I want to create this summary. If you're the CEO of, Bird Clubs International, multi-billion-dollar corporation, you might call this a report, but let's just call it a summary. So what I want to know is all of the people in Bird Club and the number of birds that they have seen. And the query that I've given us here is almost exactly what we need. And everything here should be familiar. So what I'm doing is I'm selecting a concatenation. I'm aliasing that. That's their name. I'm doing a count of star. And remember, we've always said that star means everything colloquially, and that its definition changes subtly depending on context. Now here, I would be looking at every row in the citing table. So star really, I think, in this context means every row. And I'm aliasing that. The from and where clauses are nothing that we haven't seen before. So if that doesn't make any sense, go back and look at the multi-table video. But what's happening is, in this query, what would happen is that count of star counts every row in the citings table. And it would give that number to everybody. And so this isn't really quite what we want. So what I'm going to do instead is I'm going to add one line to this query that will change that unproductive version into what we see down here in the summary. And it's only this line. I'm going to do a grouping or an aggregation. That's all I have to do. Add one line. Add one line and I get this. So what's going to happen is that MySQL is going to organize all of the rows in the citing table according to the primary key of a person. And now that count of star is going to change slightly. So before it meant every row, and now as we'll see in a second, it's going to represent every group. So the definition or the meaning of the star is going to change slightly depending on this new context. All right, so what happens? When MySQL sees a group by clause, it takes the column that we say that we want MySQL to organize by, and it figures out how many values there are, and it sets up these metaphorical buckets. It labels each one with values from the column that we gave it. And then what MySQL does is it goes through the table, in our case the citing table, and it distributes each one of those rows to the proper bucket. I know. These are imagine these are rows in the table. I know this is a bad visualization. Whatever. So as MySQL goes through the entire table, it takes every row individually and it puts it into the proper bucket. Now, once all of those rows have been distributed, MySQL goes back and does its count of star. But in this case, the star really now means every bucket or every group. So obviously you can get 3, 1, 4, 2, 3, whatever. So it's this idea of putting things into buckets and then counting the buckets that is the most important part. Well, how did I get buckets to begin with? Well, let's take a look. Here is one random row from the person table, just equals Robert Smith. And then here's one random row from the citing table. So you can see the columns here that are familiar to us from all of our work with Bird Club. Well, I have several options as a way to tell MySQL how to build buckets. Now, the one that I chose was this one. I chose the primary key from the person table. We always know that a primary key, by definition, is a unique value. So every person in Bird Club has their own unique ID. So that is an unambiguous way to create buckets. And so every ID potentially is going to create its own bucket. That's the one that I chose. But I've got several other options here. I could have chosen either one of these, for example. So I could, one of the columns I'm doing in the select clause is that I'm aggregating the first and last name. And so I could use that as the label for a bucket. Another choice would be right on the sightings table where I'm using a foreign key, right, from the person table. So that is a possibility as well. Now, I got to give you a person ID is a perfect example to use. But in this particular case, right, Robert Smith as an aggregated name might not potentially be unique. After all, remember, we have a Robert Smith and we have a Bob Smith. And if one of those changes their names, Robert Smith or Bob Smith as an aggregated name or as a concatenated name may not necessarily be unique any longer. So names are not really a good decision. We've already solved this problem a number of times. Primary keys and foreign keys are much safer. So usually you will see somebody choosing a primary key or a foreign key as a way to label those buckets. I happened in this example, just to show you it's possible, I chose the primary key from the person table, which is perhaps the quote-unquote, I don't know, farthest away, but I just wanted to show you that that's true, that we can do that. What I really want is an identifier that has a one-to-one relationship to a person. IDs are perfect for that, so they're a little bit of a safer choice for me. All right. Now, if we go back and we look at that query, I want to point out to you something that is my select clause does a concatenation and a count, and my group by clause is using the primary key out of the person table. So what you'll notice here is that my select values or my select columns are not the same as the group by columns. This is totally legit. You don't need to group by something that you put in your select clause. Why am I making such a big deal out of this? That might seem intuitively obvious. Well, here's why. We're going to get an error that will make us doubt what we are seeing here. The language of the error will make it seem like what we've just done here is an impossibility. But I want to show you up front ahead of time, it is not an impossibility. This is okay. This is legit, and this is easy to do. All right? So just bear with me. Bear with me. All right. Well, let's imagine that I want to do this. I don't want to know everybody. In fact, I don't want to know anybody who's only seen one bird. I want to see, the top sellers, the big salespeople, and the big bird sighting people. So I just want to see everybody who has a sighting number greater than 1. Now, in the past, what we would have done is we would have put in a where clause on there, and I'm not even going to write it down. I'm just going to say it because it's not right. We would say something like, give me all this blah, 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 select yada, yada, yada from all these places where birds seen is greater than 1. That's what we would have done. That's totally logical and it makes sense. And if you're thinking that way, good for you. In this case, it's just not right. What we do is we put a having clause. We're going to say having something greater than 1. And here's the big slide. So if you're taking notes, if you're writing things down in a notebook, just commit this to memory, write it down, put it on a Post-it note, and then paste that on your forehead, whatever it takes, is that the keyword having does with groups what the keyword where does with rows. So if we have a where clause in our query, what MySQL does is it starts at the top of the potential answer and it goes down the rows one by one by one and it applies the criterion or criteria from where to each one of those rows. And so what MySQL is doing is it's making a decision. Do I keep this row or do I discard this row? And that's what where does. Having does the same thing but with groups rather than rows. So when we have a bunch of groups, MySQL will start at the top of the groups and it will say, should I keep this group or discard it? What is the criterion in the having clause? Keep it or throw it away. Keep it or throw it away. So all we need to do is to swap out having where we would intuitively think a where clause belongs. And so let's just imagine this one, for example. So let's just say I have group by, I'm doing it by an ID, and in this case, I want to retain groups having a count greater than 2. And so in this particular case, what MySQL will do is go through row by row by row, and it will count how many records are in that bucket. If that number is bigger than 2, it keeps the group. If that number is 2 or less, it throws the group away. So in this case, it's going to throw away those 2 groups, and what I'm left with is this. And so this is how I can sort or discard those groups. Now, one of the things you'll notice in the pattern in SQL is because having applies to groups, you'll always see it almost immediately after a group by clause. So you'll often see this group by having, group by having. They're a pair that go together. They're sort of like, I don't know, French fries and ketchup or something. I don't know. This is a McDonald's ad now. Okay, so what we want to do is we want to come back and we want to look at those buckets. And in our case, we wanted to see every bird club member who has seen more than one bird. And so what that means is we're going to group by, in this case, still the primary key from the person table, but now we're going to give MySQL some criteria about which groups to keep and which to throw away. So retain any group where the value in the bird seen column is greater than 1, and please discard any group where that's not true. And the video could end right there. That is literally 95% of every aggregation you are about to do. It is tremendously easy to do. It's incredibly powerful. And it makes you, it turns you into an SQL guru kind of overnight, just with one little thing. But what I'd like to talk about now is the 5, 6, 7% of cases where that doesn't work. And one of the things that's going to happen is that we're going to get an error that makes us distrust everything that we just learned. But I want to reassure you, everything we learned is true. I'm just going to tell you how to handle this. So I'm changing the color of the slides, and then everything is here. It's all going to be different until we talk our way through this error. All right. So let's say now I want to do this summary. I want every month of the year, and I want to see how many birds were seen in that month. So if I do the standard query like we just did for people, I'm going to get this answer. And you'll see a little bit of a dilemma here in the month column, which is that they're completely out of order. And in fact, they show up in the order in which they occur in the citing table, which is, frankly, I made up the table, which is random. So this looks like a classic order by problem. So what I'm going to do is I'm going to have a group by. In this case, I don't have any criteria, so I will probably omit the having clause. And then at the end, I'm going to do an order by clause. Sounds legit. Now, when I'm ordering months, there's a little bit of a hiccup here. This lends itself to the problem that we're going to see, but it's not the full explanation. So if we remember back to the functions that occur in MySQL, we have a ton of date and time functions. Here are 2 that extract parts of a date, in particular the month. So if I call the month function, which is up here in the top of the black, what I get back is the number of the month. So January is the first month of the year, March is the 3rd month, August is the 8th month. That's what I get back. If I call month name, I get, obviously, the names of the months, right? January, February, March, April. Now, if I order by month name, I get the order on the left. It's so weird to see the months in this. It would be interesting to see how many people could actually identify this list as being in alphabetical order. It seems random. But what it's done is it has alphabetized the name of the month. So obviously April, August, December. The latest one in alphabetical order is September, so that goes at the end, right? Well, that's obviously not what I want. That looks like it's just random scrambling. So even though it's alphabetical listing, it's really not what I want. What I really want is the one on the right. I want to order it by the calendar number of the month. So I want it to be in January, February, March, April, right? I want it to be in that order. So my order by clause needs to use the one on the right rather than the one on the left. So I'm going to order by the month of that particular date, and then I'm going to get proper calendar order, right? Cool. So far, so good. And here's the query that I will put together. So again, I'm selecting the month name, which is that kind of prose text description of the month and account. From the citing table, I'm grouping by the number of the month, and I'm also ordering by the number of the month. Totally legit. I'm very optimistic about this. Now, quick note. We notice that the order by comes after the group by, and that I think makes sense, but I wanted to point it out explicitly. Because we are ordering the groups, we have to put the order by clause after the group by clause. It wouldn't make any sense to order things before we group them, because it would order the rows rather than the groups, okay? So I just want to be really explicit about that. The order by, in this case, needs to come after the group by, because we're ordering the groups instead of the rows. Okay, good. All right, so I'm optimistic about this. Going to be great. Can't wait to get into the terminal window, put it in, and it doesn't work. Now, this error 1055 is the one that you're going to get, and I'm going to give you in. It's pretty long. It's about three rows of text long, and I'm not giving you the whole thing because the salient properties that we need to see are immediately at the beginning. So if you get an error 1055, it's going to be long. I've cut the error. We're not seeing it all. Okay, so here's what it says. It says that expression number 1 of the select list, and I put that in white so that we can identify it, is not in the group by clause. And so it wants the month name to be in the group by. But we've already talked about this. We said that I don't need the same things in the select clause that I have in the group by. But what's up? Why does that happen? All right, well, let's dive into this one to see what's actually going on in this problem. All right, so when we group by the month of a particular date, what happens is that the rows that go into that bucket have distinct dates. So just imagine, I just made up some of these, right? So here's one from 2018, here's one from 2017, here's one from 2019, whatever. Now, the problem is that MySQL can't figure out that these are all in the same month. They're all 06s, right? And if I put the month name out there, all of the 06s are going to produce June. They're all the same. Well, the problem is that MySQL can't see that. It only sees distinct, unique date values that are not the same at all, and so it freaks out a little bit, and that's the problem. So the problem is that we are extracting part of that column. We're not using the whole column, which we have previously done in this video. We use the entire column as a way to group, but now we're grouping by a portion of a column, and that leads to this problem that we see there, this error in MySQL. All right. So if we take the months of the year, the number, right, like 06 or 02 or 12, and we convert that into a month name, MySQL is worried that this is what is about to happen, that the month name in that group is somehow different. They're all different. That's a possibility, and MySQL is worried about that. Now, of course, we know it's not going to happen, right? We grouped by the month. So if all of the groupings have month 06, they're all going to be June. So what's MySQL worried about here? It just doesn't seem to make any sense, right? All right. Here's the solution. What we do is we give MySQL permission to use any row in that group to extract the month name. And this takes the pressure off of MySQL. It's worried that they're all going to be different, It doesn't know how to select one row out of that group in order to extract a proper month name. So we tell MySQL, hey, do it with any value in that group. We don't care. Choose any row in that grouping, select the month name out of that, and use it, because we don't care. And this solves the problem. Now, I know this is not maybe necessarily something intuitive that you would have arrived at your own. Like, just going through the grouping we've done so far in this video, you would never think of having to apply an any value criterion. But this is exactly the thing. So it's going to choose any row at random in that group, extract the month name, and use it. MySQL doesn't know, hey, man, they're all going to be June. It doesn't even know that. We know that as humans, but MySQL doesn't, right? Okay, why does this happen? Little digression, sorry, I'm going to change the slide color here, and I just want to talk through why this is going to happen. For us, we have human intelligence, we have quote-unquote common sense. And if we look at those two buckets at the bottom, and you look at the dates, sure, the years are different, sure, the days are different, but the months are all 06. So we know intuitively and instinctually, commonsensically, that every one of those is going to be June. These are the same, right? MySQL can't do that bit of logic. This is actually called the transitive property of equality, and I know it shows up all the time in math. Sorry about that. We'll do it in common sense terms here in a second, but this is what you see in math, right? Like if two numbers or two qualities, A and B, happen to be the equal, if A number equals B number, and then we also notice that B number equals C number by the transitive property, therefore A number equals C number as well. That must be true. Now, we've embraced this so much, it's not just a math principle, it's actually a common sense principle that we apply to the world all the time. But MySQL doesn't have this bit of common sense, and so it can't do it. Now, in our version, it looks a little bit more maybe like this. If we organize all the rows of that bucket according to the number of the month, check, and we also know that there's a correlation between the number of the month and the name of the month. All the 2s are February, all the 6s are June, all the 8s are Augusts. If we know that's true, then it makes total common sense to us that the rows are also organized by the name of the month. They are always organized by January or February or September or October. That is total common sense to us. The problem is, MySQL has not been programmed with this type of common sense. So on the human side on the right, intuitively obvious, like everybody is going to see that. This is just what it means to have common sense in the world. We can see those sorts of patterns. MySQL has not been taught the transitive property of equality, and so it can't jump to the same conclusion. And because it can't, that's why we get this error. And because MySQL doesn't know the transitive property, that's why this error does not look like it's common sense to us, right? Okay. So in reality, the bucket on the left and the bucket on the right down there are equivalent. And as human beings, we see that immediately. That is intuitively obvious to us. But that equivalence is not intuitively obvious to MySQL because it doesn't know what the transitive property of equality is. All right, end digression. Okay, now let's imagine that we didn't know necessarily yet any value, and let's try to placate MySQL. The problem that it pointed us to was that a column in the select clause was different from the column in the group by clause. Now, cough, cough, cough. We have seen all through the video that it's possible to do that. Totally legit. So do not leap to the conclusion that you have to have the same columns in select as you do in group. That's not the answer here. Any value is 1. But let's pretend, let's imagine now that we're like, well, okay, let's just make them the same. So now I am going to select the month name, and I am also going to group by the month name. So both of those now are the same. This seems to satisfy MySQL's beef with us, right? Select and group by are now the same. All right, but now remember, I still have to do order by in terms of the number of the month. If I change that to month name, I'm going to get alphabetical order, and that is not what I want. I want this in calendar order, so the order by still must remain in terms of the month. All right? But hopefully we're great. I'm very optimistic. Can't wait to jump into terminal. Can't wait to paste this in. Can't wait to see. Now we get another problem. All right. So we get that same error again. It's our friend 1055, and this time it says that the expression number 1 in the order by clause, which is here in white, is not the same as the group by clause. Like, well, come on, we can't always have all three of these things be exactly the same, right? Now, in this case, I have to select month name because I want the prose version, the text version of the month. I have to order by month numeric to get it in calendar order. So what gives? Well, we've already seen the solution, believe it or not. The solution is to use any value again. And so I can use any value wherever this problem starts to show its ugly head. If MySQL feels that I have a problem in the select clause, just put any value up there, right? If it says that I've got a problem down in the group by or order by, just put any value down there. And so I can solve this problem by using the any value criterion, and you'll see here this is the the summary or this status report that I get. But again, the criterion is not necessarily that all these things need to be the same, but when we're extracting a part of a column, MySQL sometimes will freak out because it doesn't know that if I'm grouping by month, I get the same group as if I grouped by month name. That's not necessarily obvious to MySQL. So there are things that I can do to help solve that problem, and the any value criterion is the really one to use. So again, use any value in any part of an aggregation query that gives you problems. It might be up in the top, it might be at the bottom, it doesn't really matter. And the problem is that MySQL doesn't know that any row at random in that group will be sufficient to help us get to the end, right? This is a case of like all roads lead to Rome, right? There are two different paths, two different roads, but we're going to get to Rome either way. And MySQL can't tell it that's where we're going to go. So use any value as a way to solve these problems. And so between where we started here and any value, I think that's going to solve like 99.999% of the aggregation problems that you're ever going to face, right? All right, but just to reiterate, here's another one, and I'm going to let you do this one on your own if you'd like to. This is using the book database that we created and we've been creating in the last couple of videos. But again, just to take a look at what's in green here, right? So I'm selecting the book title. I'm selecting a count. I'm going to, again, count of star, because I'm using a group later. Count of star means count the rows in every group. And I'm aliasing that as how many authors. But I'm grouping by a foreign key out of the roll table, but I'm ordering by my count in descending order. So the select, the group, and the order do not need to be the same. But when I start extracting pieces of one of those columns, that's when MySQL might get into and give me a bit of a headache. And using the any value function or the any value criterion is a way to solve that problem. Right? All right. Well, that's it for aggregation, grouping by, using the having clause. I know we didn't do any terminal work in this video, but go back, take a look at all of the things that we did, and you can practice those in the terminal window on your own. Now, we are going to see this kind of group by having again in a subsequent video when we get to subqueries. So study up on this, make it part of your arsenal, and we'll see you soon. Thanks.